Hi, I'm Bruce Kyle. I'm an architect evangelist at Microsoft. I work with software companies in the Pacific Northwest. I'd like to introduce Stuart Solarier. Stuart is a software architect with CheckFree and is a Microsoft Most Valuable Professional.
Hello, I'm Stuart Solarier, and I blog at visualstuart.net. I'm a Microsoft MVP on connected systems, and until now, most of us have been programming in C# 1.0. From that .NET 1.1 era, and even if we've got a newer version of the language, we're still using it as if it were C# 1.0. We're going to take a look at what's new since 2003. What changes the way we program? I'm going to focus on the language, not practices, not applicability, not even usefulness. So opportunity for abuse abounds. We're going to do just enough to be dangerous.
Hey, Stuart. What's today's Whirlwind?
So today we're back looking at C# 3.0 and Lambda expressions, a concept so big it barely fits on a slide. There's Lambda for you. You remember we were talking a while back about anonymous methods being a way to write a delegate with a block of code in line, not having to create a separate method just to be able to have a method name that I can pass exactly one place. So that had a little bit of the flavor of functional programming, but the syntax was still very much imperative programming. And it was verbose. So Lambda expressions are a way to write anonymous methods, nothing new there, using a more concise declarative functional syntax. Now, if you don't know what I mean by declarative, I want you to think of a spreadsheet. I've got one cell, and inside of it I type equals, so this is a formula, that cell plus this other cell. I'm just declaring what the result is that I want. I'm not saying how to get it, when to get it, how it gets done, just I'm declaring the result that I want. I know that if I had a spreadsheet full of those kinds of fields, cells, that the people who design the spreadsheet will eventually become smart enough that they only compute the values that I can see, at least at first, so that I get a good experience with that. Hide that level of detail from me. I just want to write that this cell equals the value of that cell and this other cell. Similarly, if I go and change the value of that other cell, my sum changes. There's an eventing model that's happening. Hide that from me. I just want to declare the result that I want. You go figure out how to make it so. That's declarative programming. I'd like to introduce you all now to the Lambda operator. Here's what it looks like. It is not equals greater than. It is pronounced goes to, as in x goes to x plus 2. It's a mapping in the sense of a function here. A function takes x and returns x plus 2. So Lambda expressions are where I'm using a single expression, not a whole statement, just a single expression as a lambda. So in our top line here, I'm declaring that I'm going to have some kind of delegate. I call it some delegate. And again, we're just declaring the shape of, the signature of a function. So this some delegate is a function that takes an int and returns an int. Now let's actually create just such a function. We'll call it square int. And I'm going to write it, as I show here in red, as a lambda expression. So I'm going to write x goes to x times x. So compiler, go write a function that says I take an int and I return that value times itself. So if I call square int on 5, I expect the result j is going to be 25. In our first lambda, the one that's lambda expression, the one that's shown in red there, we had a single parameter. If I've got multiple parameters, I just enclose them in the parenthesis syntax, much like I would if I were writing parameters to a method. So here I've got the pair xy goes to a value is x equal to y. And we're letting the compiler infer the types of x and y, and infer that the return type must be bool because that's what equivalence returns. I can also indicate the types of the parameters getting passed into my lambda. In this case, I need to indicate that s is of type string so that the compiler knows what to do when it sees s.length. So here's an expression that maps the pair x and s to asking, is the length of s greater than x? I could also have lambdas that take no parameters at all, and again I use the same parenthesis syntax that I would find for a method that takes no parameters. So here's a lambda that just writes "Hi Mom" to the console. Those were expression lambdas. I can have statement lambdas, so I might need to do more things than comfortably fit in a single expression. Maybe I need to do an intermediate assignment. And so on the right-hand side of the goes to, I write a pair of curly braces and I write a compound statement inside of that. So in this case, the string w gets assigned to, and then we use it. So if I invoke this delegate called hello, passing it the string world, I hope I get out the string hello. I get written to the console a string hello, comma, world. So just a fancy way, if you will, of writing a delegate. You probably want to keep those lambda expressions short. After all, if you start getting into a long statement there, this doesn't have the flavor of functional programming anymore at all. And you're probably better off writing a delegate itself, because that's a different style of programming, and the styles mix well in some ways and maybe less well in other ways. So there are some standard delegates to help you write your lambdas, handy things to know. So here are some delegates defined in the system namespace called func. They're overloaded by the number of arguments that they take, and include a return type, tResult. And so now I don't need to manually write delegates that take up to 4 parameterized types and a return type. I can just use the handy func delegate syntax. So, got the func? Here's an example. Before, when I wrote my lambda expression square int, I needed to declare a delegate before I did that. And now I can just use the delegate func of int, which means a function that takes an int and returns the second parameterized type, returns an int. So that just makes my syntax a little bit nicer to write. The second example there, we have a func, which is a delegate that returns a bool and takes 2 parameters, an int and a string. And then I write my my lambda expression to the right. We've got some more of those standard delegates that are defined in the system namespace. So a predicate, if you remember your formal algebra from college perhaps, a predicate is something that takes one argument and returns a bool, yes or no. So we have a delegate defined to represent predicate, so that we'll know one when we see one. Similarly, action is a lot like func, it's just we're saying the return type is void, there is no return value. So let's take a look at a standard query operator. In this case, I'm just looking into the system.link namespace. Pay no attention to that's where we happen to find this thing. We're not doing link quite yet, so don't freak out. I've got a static class called enumerable. We've seen static classes before. And I have inside of it an extension method. I can tell it's an extension method because it's using the this keyword to decorate the first argument to the static method count. So it also takes a predicate, in this case declared in terms of func instead of predicate. I don't know why. And an example of me using this this count extension method is, let me new up an array of digits and then call digits.count, and instead of writing somewhere else a delegate to pass in as that predicate, let me write it inline as a lambda expression. So I'm going to count, and I'm going to map all the n's, all values of n, to n mod 2 equals 1. So I'm counting the odd digits. How many odd digits are there? And I hope we get the value 5, at least for the array that we put in. So again, we're just using a new syntax for writing anonymous methods, which were a way of writing delegates.
Hey, thanks, Stuart. For more information for software developers, see the US ISV Developer Evangelist blog on MSDN.
Hey, it's been fun. Again, I'm Stuart Solarier, and I blog at visualstuart.net. See you next time.